Good morning, students. So, in today's class, we are going to study about the comparison of Butterworth filter and Chebyshev filter. And we all know that these two filters are used for converting the analog filter into an analog filter to have a better frequency response. So, now let us see the comparison between the Butterworth and Chebyshev filter. So, in the case of Butterworth filter, if you see the order of the Butterworth filter will be very high compared to the Chebyshev filters, because for higher order only the ideal filter response will be nearly equal to approximate filter response. So that's why we used to prefer higher orders for Butterworth filter compared to Chebyshev filter. But in the case of Chebyshev filter, that is different. So the order of Chebyshev filter will be lower as compared to the Butterworth filter. So if you design a Chebyshev filter of lower order, that is enough here in the case of Chebyshev filter. Because the Chebyshev filter magnitude response function itself, it is a little bit complex because it involves Chebyshev polynomial and other mathematical function. So that's why if you use the order of the Chebyshev filter low with the lower order, that is enough for performing the Chebyshev filter operation. And the second important difference is the Butterworth filter, it requires more hardware. But in the case of Chebyshev filter, it requires less hardware only. And in the case of Butterworth filter, if you see the cutoff frequency, the filter has a cutoff frequency. It is not equivalent to the passband frequency. So there is a formula to calculate the cutoff frequency, which is given by omega c equal to omega p divided by 1 by ap squared minus 1 whole power 1 by 2n. Whereas in the case of Chebyshev filter, when you see the pass cutoff frequency, it is equivalent to the passband frequency. That means omega c, it is equivalent to omega p. Then, when you see the fourth difference between the Butterworth and Chebyshev filter, the transition band of the Butterworth filter is very wide compared to the Chebyshev filter. Whereas in the case of Chebyshev filter, the transition band is very narrow. And next one is when the see the all the poles of the filter will always lies on a circle having the radius r equal to omega c. Whereas in Chebyshev filter, all the poles of the filter it will lie on an ellipse having the major axis r tau and minor axis small r. And the next one, the Butterworth filter has no ripples either in the passband or in the stopband region. Whereas in the case of Chebyshev filter, it is having ripples either in the passband and stopband region. So the Butterworth filter does not have any type 1 or type 2 filter. But whereas in the case of Chebyshev filter, it is having type 1 and type 2 filter. So in the case of type 1, there is a ripple in the pass band. For type 2, there is a ripple in the stop band. That is the difference exists in the type 1 and type 2 of the Chebyshev filter. Thank you.